Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the pressure exerted by 1.0 mole of H2S behaving as a van der Waals gas when it is confined under the following conditions at 273.15 Kelvin in 22.414 dm cube. So the first thing we have to notice is that we're told that we're dealing with a van der Waals gas, and we're also given the number of moles of gas to be 1.0 mole. And we're told that it was confined under the following condition, where we're given the temperature to be 273.15 Kelvin and then the volume to be 22.414 dm cube. So since you know that we're dealing with a van der Waals gas and we've been given the number of moles, the temperature, the volume, the next thing you have to do is to write out the formula for determining pressure of a van der Waals gas, which is just simply pressure is equals to RT divided by the molar volume minus the parameter B minus A, which is the second parameter of the van der Waals gas, divided by Vm squared. Of course, R is gas constant, T is temperature, Vm is molar volume, and this is the formula we're going to need to be able to solve this question. So the first thing you have to note is that we know the gas constant R because it's a gas constant. It's a constant, so it has like the value, known value. We know the temperature because we're given the question. We know the volume, but we're told to determine the molar volume here. So when you're asked to determine molar volume, when you're given volume, the molar volume is just simply the volume divided by the number of moles. We're given the volume to be 22.414 dm cube and the number of moles to be 1.0 mole. So hence the molar volume is just simply 22.414 dm cube per mole. So that is basically the molar volume. So now we have the molar volume, the gas constant, and the temperature. Now we have to um, get the values for A and B to determine the pressure, because of course when we've determined the value for A and B and we substitute those values as well as the values for R, T, and Vm, we can determine the value for pressure. So according to the Physical Chemistry Atkins textbook, the 11th edition, which this question is from, the resource section of that textbook shows you the A and the B values for all gases. In this case, we're dealing with H2S. So looking at the A and B value, the van der Waals parameters for H2A gas, we determine A to be 4.484 atmosphere dm6 per mole squared, while B is simply 4.34 times 10 to the power of negative 2 dm cube per mole. So these are the values that we need for this question. So now we've been able to successfully determine all the parameters that we need to solve this question. We just can simply substitute. So we have pressure is now going to equal RT, which is just 0.08206 dm cube atmosphere per mole Kelvin, divided by, sorry, not divided by, times actually. If I almost forgot temperature, times the value for temperature, which is 273.15 Kelvin. So times 273.15 Kelvin. Okay, all of that information divided by Vm minus B. So the molar volume 22.414 dm cube per mole. Okay, minus the value for B, which we know to be 4.34 times 10 to the power of negative 2 dm cube per mole. So that is the other one. So all of that information minus A, which is 4.484 atm dm6 per mole squared, okay, divided by Vm squared. So what is Vm? Molar volume is 22.414 dm cube per mole. So 22.414 dm cube per mole all squared. So now this is basically what we really needed, right? We've successfully substituted everything. So now all we just have to do is to simply cancel out whatever we can cancel out. We have per mole Kelvin here and we have Kelvin, so the Kelvin can cancel out. So we've successfully canceled that out. So we're just simplifying as best we can. So next we have pressure is equal to 0.08206 times 273.15. When you do the calculation, you end up getting 22.41469. And then of course we have the atmosphere dm cube. So I'm just going to say atmosphere dm cube per mole, okay? And then you have the denominator. We're going to do the calculations. 22.414 minus 4.34 times 10 to the power of negative 2, which is just 22.3706 dm cube per mole, okay, minus 4.484 atmosphere dm raised to the power of 6 per mole squared. So that would be 4.484 atmosphere dm 6 per mole squared, okay, divided by 22.414 dm cube per mole all squared is simply 502.3874 dm6 per mole squared. So of course you cancel out dm cube mole, you cancel out dm6 mole squared. So you have we've canceled, so now we've canceled out all of the units, right? And now we can just focus on determine the answer for pressure. Like for example, we have atmosphere is the only units that remains, atmosphere on this side is the only unit that remains, which confirms the fact that we're doing our calculations correctly. So let's say pressure now is just going to be 22.41469 divided by 22.3706 will give you 1.00197 atmosphere, okay, minus 4.84 divided by 502.3874 would give you 0.0089254 atmosphere. So of course, when you input this information in a calculator, you end up with 0.99305 atmosphere, which you can successfully approximate to two sig figs, because in chemistry you can't just leave your question with the raw value. You have to put the lowest number of significant figures you got from the calculation, and we can see the lowest number of significant figures is two sig figs because the number of moles was two sig figs. The volume is 5 sig figs, the temperature is 5 sig figs, so the number of moles takes the cake, and it's gonna be our answer has to be in two sig figs, the final answer. So the pressure is just 0.99 atmosphere. So this is the answer to this question. I did another question on my channel that is very, very similar to this, and it's going to be on the screen, where you have the exact same type of question, but just different values. It's going to help you guys practice. And I also go in detail in giving the explanation. So I also wanted to mention that this is just me doing a bunch of questions in the physical chemistry Atkins 11th edition's textbook. So if you are studying physical chemistry or thermodynamics, make sure you watch my videos, subscribe, and like it. I also wanted to mention that if you're a student who's struggling or trying to improve or succeed in all your STEM related courses, whether you're in middle school, high school, or college, I tutor students who are trying to be the best version of themselves in academia to succeed, as well as mentor students to help them navigate their career path. So if you want my services, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.